Hello, my name is Erica McCarty, and today I'm going to be talking about the general circulation of the atmosphere. The first thing I will be discussing is the direction of the wind. Wind moves horizontally or in a straight line and seeks to move from areas of high pressure to areas of low pressure. The closer to the surface of Earth, the higher the pressure. Therefore, air masses seek to move up in the atmosphere towards low pressure areas. The greater the pressure difference between zones, the faster the wind moves. In the northern hemisphere, the high and low pressure systems will look like this diagram, with the winds in high pressure zones moving outwards or diverging clockwise, and the low pressure systems moving inwards or converging counterclockwise. However, in the southern hemisphere, these systems flip in their direction. In the southern hemisphere, winds in high pressure zones will still be diverging, but will now be diverging counterclockwise. Therefore, winds in low pressure systems will be converging clockwise. The next topic I will be talking about is the Coriolis effect. As stated in the last slide, wind moves in a straight line. However, because Earth rotates, this line is deflected and appears as a curved line. This process of winds curving is known as the Coriolis effect. This effect only impacts wind direction, not speed. Because of this effect, wind direction will always be from high to low pressure. The pressure gradient will cause the air mass to start moving. However, the Coriolis force acts as a right angle to this air mass. Eventually, the Coriolis force is equal to the pressure gradient force, and the air mass moves parallel to isobars. These are geostrophic winds, and they only occur in the upper winds, where there is less friction. Friction reduces Coriolis forces. Next, I will be discussing why air rises and descends. Warm air is lighter than cold air, therefore warm air rises, creating low pressure zones. Conversely, cold air sinks, creating high pressure zones. As the diagram demonstrates, land heats up and cools down faster than the ocean does. As the land heats up from the sun, the air nearest the surface does too, and then begins to rise. Once higher in elevation, the warm air begins to cool, forming clouds. The cooler air then sinks, which spreads across the surface and blows from the ocean to the land as sea breeze. This process then starts over. The next topic I will be talking about is how climate is affected by the general circulation of the atmosphere. Where an air mass collides with another, convergence occurs, causing air to rise. Where air masses move away from each other is where air descends back down. Near the equator, we have rising air pressure zones known as equatorial low. The upper level air moves toward the 30-degree north and south latitudes and sinks back to the surface, which is known as the subtropical high. This is where we will find deserts, as the winds are diverging, and therefore producing good weather, few clouds, and little precipitation. The subtropical and polar highs are areas of high pressure zones, so there is little precipitation. At the surface, air will either move towards the equator or towards the poles. If air moves toward the poles, it is called the westerlies. If air moves toward the equator, it is called the trade winds. As warm westerlies move toward the poles, they meet with cool polar easterlies in the subpolar low, creating a stormy belt known as the polar front. Eventually, the cold polar air subsides and spreads towards the equator. The equator and subpolar zones are both low pressure zones, so there is lots of precipitation. Lastly, I will be talking a little bit about something familiar to Oklahomans, tornadoes. Tornadoes are formed in low pressure zones where air converges from below and diverges up above. Atmospheric instability allows air to move vertically. Funnel clouds then extend from cumulonimbus clouds and rotate. Air masses play a major role in why Tornadoes Alley has its name. As the diagram shows, cold, dry air from Canada, warm, dry air from New Mexico and Arizona, and warm, humid air from the Gulf of Mexico all collide as fronts in Tornado Alley, which is the perfect flat area for differing air masses to meet.